let's start. So this tutorial will be about milestone 1, and I will be walking through one of the functions that you will need to write. And yeah, let's start. So milestone 1, we have 4 parts in our code. We have 2 APIs, the street database library and the street map library, and the main executable and the tester executable. The lower level API streets database library cannot be modified, and you will be communicating to it to get all of the information you will need. Your main executable and the tester executable will be calling the street map library that you will write. And the tester will test for queries into your library, and you will be using the lower level library to complete the queries. So first thing to do is to read the handout really carefully, because it will contain many important information you will need. And whenever you have questions, first refer to the handout. Then in your code, we're expecting to see at least one global variable. And why do we need one global variable at least? To pass the performance tests? Or anyone? Okay. So you will be needing to store information so that you can quickly grab the information when you need them. And if you just do the calling the lower level library each time, you won't have enough time to do it. If you believe that you can do it without storing data, then yeah, prove to your TA and to the tester. Here are just some containers from the STL that you will likely use and choose. And we will be deciding which container we choose depending on the usage. So the map. How is the map stored in the lower level API? We have intersections where streets meet and street segments that are connecting the intersections. So there will be one street segment between each 2 intersections. And each intersection will have a unique intersection ID, and each street segment will have a unique street segment ID. What you're given in your starter code will be 2 includes to the m1.h and street database API.h. This is the lower level API that we will be giving to you. And both of these should not be modified. The load map will be called at the beginning of the program execution, where you are loading your map related data structures, and the close map will be called at the end to clean up. It should be straightforward. So first steps for M1 is to compile and run the tester code, EC297 XSS1 for M1. And because you have not modified anything, the result will be many compile errors saying that your functions have not been declared, undefined reference to functions. So Let's go to the m1.h and see which functions we will be working on. So all of the functions in m1.h are expected to be implemented. And in this tutorial, I will walk through writing this function with you, which returns the street segments for any given intersection. Find street segments of intersection. So next step is to go into your C++ files and implement all of the functions in the m1.h header file, but without anything in them. So create empty functions for each, and make sure you pass the compiler by returning something. So in this case, we're just creating empty functions and returning empty stuff to just pass the compilers. And if we run the tester executable again, you will be seeing this. The test summary saying all of the tests are failed because we don't have anything implemented, but you will be able to see all of the tests being run by the tester. And your goal for M1 is to pass all of the tests here. Let's look at one of the functions then. So the find intersection street segments, find street segments of intersection function returns a vector of all of the street segments connected to an intersection, specified by the intersection ID. And in this case, only input is an intersection index number, which means that we will need to get the intersection information from outside of the function, which is the lower level API, street database API. And let's open up the street database API. This is just a small snapshot of the header file. So we can see that the street segment information are stored in struct. And each struct will contain one OSM ID. OSM IDs are just unique IDs globally. So the ID will be unique globally in terms of intersections, street segments, and cities. So it will be a huge ID. Intersection index from and to means the two intersections the street segment is connected to. One way, if one way is 2, then this is a one-way road going from to 2. Otherwise, it will be bidirectional. Curve points means the number of curve points between the ends. This will be useful when you are drawing the map. Speed limits and the street ID, street index. So note at this point, we have already seen intersection index, street index, and street segment index. And when you scroll down into the header file, you will see these three functions that will be needed while implementing this specific function. The first function, get non-intersection street segment, returns the number of street segments connected to the intersection from the intersection index. And get intersection street segment will return the street segment index for each of the street segments connected to the intersection using a segment number. And get street segment info will then get the info for the street segment from the street segment index returned from this function. So the naming convention of all of the functions in the street database API will follow this. Get means that you are getting something. And this operation usually is O1 complexity. Intersection means that you are passing in an intersection index. Is the entity we're looking at. Street segment means that this is the thing that we are looking for. And because we have the num here, then it means that we have intersection and we're looking for the number of street segments. So how will this work then? Say we have this intersection at St. George and Galbraith. This intersection is connected to 3 street segments like this. And we have intersection ID 232. So we call the getNum intersection street segment 232. This will return the number of street segments, which is 3. And for each of the 3 street segments, we are getting their street segment index from calling 0, 1, 2. So 0 to intersection street segment -1. And after getting all of the street segment indices, get the street segment info respectively. And just note that all of the indices types here, intersection index, street segment index, are all type defs to int. So if you accidentally use an intersection index to access the street segment, the compiler will not tell you anything because they are of the same type, but you have to be careful. So to avoid that error, try to decide a naming convention between your group members. Something as simple as -I for intersection, -S for street segment. And make sure all of your group members follow that convention. Okay. And next, let's open up a text editor, or if you have your repo ready, you can go VNC into your UG machine and try to implement this function using the 3 function calls to the lower level API. And we'll be back in a few minutes. See how you will do. And let me know if you need the function definitions for the 3 functions. Everyone got a chance to try? Anyone need more time? I'll continue then. So your function will look like this. Start with a for loop. I goes from 0 to get num-intersection street segments intersection ID -1, I++, and you get the intersection street segment using I and the intersection ID to get the street segment ID and push back into the street segment IDs vector and return. And if we just do this and run the tester again, so this command will only run the testers containing the words intersection. And if we just run this tester again, you will see that the functional test has passed, but the performance test failed. What should we do for performance then? We have 3 levels of speed requirements in this milestone. So we have the high speed requirement that needs the function to be really fast. We are expecting you to create data structures to allow you to rapidly obtain the required information. And we have the moderate, which means that the function is speed tested, but you can pass it with some more straightforward implementation. And none means the function is not speed tested. And the function that we just wrote has a high speed requirement, which means that we will need to create new data structures for it. So consider what we just did for function. What is the complexity? Yep. Yep. So what is n then? Yeah. You can get the chunky. Yeah. Yeah. So it is of n or all of k, where k is the number of street segments connected to the intersection. How can we speed up our function then? If you look at the comment we provide to you in load map, we gave you a massive hint where we're creating data structures. And what data structure can we use for this function specifically? Let's look at this function. We have the input intersection ID, which is an integer, ranging from 0 to number of intersections -1. So this is a continuous range starting at 0. We have the output of street IDs and a vector of integers. And if we look at our SQL data structures, vector, list, map, and unordered map. So vector takes in an input as an integer, which ranges from 0 to the size of the vector, and output is templated. List takes in an iterator, output is templated, and you can use the advanced function to obtain any element in the list. So the advanced function will then just take the iterator and advance by input number of steps. Math takes in two templated values and similar to unordered map. And if we think about it, which data structure can be accessed with an integer intersection ID? Vector map, unordered map, and list inefficiently because it's O(n) times. What can these data structures contain? Anything, because they're templated. And the complexity are as follows. Vector can obtain anything from index in O(1) time, list O(n) times, map O log n, unordered map O(1). And we would like something less complex than O(n). Which means we are picking between vector and unordered map, which both have O(1) times. And a vector, if you want to access any element in the vector, you will do one direct memory access, which means one load instruction to the memory. The load instruction is covered in 243. For unordered map, we need to call the hash function to get an index and then perform the direct memory access. Which means that the hash function is slightly lower than vector. Because the hash function takes time. Then when do we need the hash function? The unordered map. We need it when the input we have is not an index. Or the index that we're looking for is a huge one that exceeds our memory limit, for example. And many of them are just empty. We are only using a really small portion of that. Then we will be using a hash function. And if we are indexing using, say, string, or just something that's not integer. Does that make sense? Which means that in this case, we will be using vectors. So we then create a vector of vector because the inner vector is the output we are getting from the function. So we create a vector of a vector called intersection 3 segments and make it global such that all of functions can access them. Then we populate the global variable inside load map, which is called at the beginning of the program execute 1. So what will this data structure look like? 3-segment index is an integer type defined. So we have the outer vector going from 0 to number of intersections. And each of these contain a single vector of integer. So it will look like a dynamic 2D array of integers, each containing 3-segment indices. Okay, does this make sense? And let's break out into teams again and try to write how you would fill this data structure inside load map. And we'll be back in a few minutes. Anyone need more time on this code? Or I'll just continue. I'll just continue then. So after you load the map, the first thing is to resize the global variable outer vector to be the size of number of intersections. Then you loop through all of the intersections from 0 to number intersections -1. And in the inner loop, you are calling the number of intersections 3 segments for each of the intersection and getting each of them and pushing them back into the inner vector, like this. After this, you will have a vector filled with vectors of street segment index. And you can just index using the intersection index into the outer vector. Makes sense? Then if you just write the actual function itself, go into the global variable, index using the intersection ID, and it will return the vector of street segment indices as required. And the lookup time for this is 01 with a single memory access. Then if you run the tester again for the intersection test, it will pass both the functionality and the performance. Yep. Just note that there is a performance test for load map as well, but it will be in a few seconds, so it's a long time, so that you can have enough time to load your data structures, but just make sure it's not too long. And that's it for today's tutorial material. And if you have any questions, you can ask. And just a slight reminder that you will be expected to read the handout before coming to the lab. If you did not, then your TA will make you read it. Okay. If you have any questions, I'm here to ask. And if you don't have any questions, see you next week.